to join and see what program is going on here.
Oh, very nice. Welcome.
Thank you, sir.
Yeah. So basically, it is an educational program we have, and it is meant purely voluntarily organization where we have uh, put together experts from international uh, background, where all the experts in different fields, science, especially in the science area, science, technology, math, and engineering. So basically, our goal is to interact with the kids mainly from the rural area, if possible, and of course also from the city area, both, but mainly focused on the rural area. Interact and guide them in general science, uh, their educational goals, and also we promote English as an international language. The idea is that world is becoming small, and English is the international language. And now workforce, you can see, is very mobile. We go all over the world to work, so we have to really prepare our young generation to be able to fit in anywhere in the world. So they should not be taught only the Indian culture, but international culture and English, the language, and of course science and technology, because that is what will take them to other places. So that's what we do. We have right now two meetings going on every Saturday and Sunday this time. Saturday is for kids, where we do the science education, and Malik ji is the chair of Saturday meeting. He's here right now, present in the meeting, and he mainly interacts with the students and asks their general science question. He is a former retired Bhabha atomic research science physicist. I am his backup. I am a former IBM Intel retired engineering manager in the United States. So basically, and then other people are also volunteers. There are several volunteers, just not two of us. And so that's what we do on Saturdays. On Sundays, we do mostly help with the college graduates in the placement, how to do the interview, how to write a resume, how to speak good English to impress other people, and of course, basically to prepare to seek a job somewhere, and in India or outside. We also on Saturday, Sunday advise students. Suppose if any students want to come to American University for doing masters and PhD, we guide them. If they want to go to London or any European countries, so we have experts from all different countries, and it is a kind of open forum for anybody to ask any question on Sunday, and Saturday is focused on uh, middle school and high school students. I hope we answered your question. Malik ji, you want to add anything? Mute,
Sir,
please.
you are on mute, sir.
Done a very good introduction to the whole thing. I think it's so. But Amit ji, he comes. He's a old part timer, isn't it?
No,
Hello.
he's here first time.
Oh, is it?
Yeah, he is mainly from the education department. He's
Yes,
trying to
sir.
understand.
I'm joining here first time. Like I'm from the Bihar Education Project, Bihar District Agriculture Office, Hajipur, Vaisali District. And our DPO, sir, District Project Officer, sir, shared me the link, one paper, and he said join on Saturday 8 p.m. and let's see what program is going on here, and I'll update to them, sir. Like,
So you're in the education side, is it? Hello.
yes, sir. I'm from the Bihar Educational Project, Educational Department, sir.
Oh,
District Education.
sorry, I was a bit late. So what kind of project is that?
Sir, like we are as a team in Bihar Agriculture Bihar Education Project BEP. It's called SSA Sarv Shiksha Abhiyan, where we have the schools 2295 schools are there, from primary school to middle school and high schools. So we have a students in that school, and if the program is really helpful to our students also, I can convey to my DPO sir or district agriculture officer sir regarding this program, and then they will discuss on you or any like higher authority person. Like I'm here only to see what type of program is going on here, so that I'll give them a brief regarding this program, sir. So I joined. He shared me the link to join and see the program, what type of program is going on, so that we implement in our districts also and in our state project also.
Oh, that's very nice of you actually. No,
Yes, sir.
so as Amarnath ji has just now told you that basically we are emphasizing the
Yes, sir. I totally understand that.
spread of science among our young students. Our students must develop critical thinking skills. So these are the things we have in mind actually.
Right,
And
sir.
Pankaj,
Our education, as in Bihar state, they think that's a very outer side of a state, but our DPO sir Santosh Kumar is there, district project officer. He's trying
hmm,
to like make our government schools and primary schools better than the government like private schools, so that our government school students are able to present themselves on a higher stage anywhere. So that's the reason I'm here only, and I see and check, and then I'll report to my DPO sir, and they will like connect with the higher person. I don't know the name, but definitely they will going through this session, so that we implement also the same in our schools, in our primary government schools, sir. We have government
Also,
schools, sir.
yeah, also for your information, every session we have, we record it. So every our previous meeting, if you go to YouTube, you can see everything. So while they are talking, I will share some of the YouTube, list
Link.
of the previous session. So anybody from anywhere can see. So you have to do is search Mithila Digital World Family, and then
Sure,
all
sir.
videos
It's really
come up.
helpful for me.
Yeah. So it has been going on for the last a few years,
Sir,
and
you are sharing any link here, or shall I write?
I'll share with you. Let the session continue. What I will do
Okay.
is that maybe after the meeting, if you stay, we can give you all the more information regarding this organization. We have our own charter. We have
Definitely, sir. I'll stay here only, and
yeah.
in after this session,
Yeah,
you can.
I don't want to take any more time from the students because there are a bunch of students here, and let them.
Sure, sir. Sure, sir. Sure, sir.
Okay,
Okay.
we'll talk after 9 o'clock further on this subject.
Sure, sir. Okay, sir.
yeah, yeah,
And
just
yeah,
to add, Amit ji, so what we basically we see in Bihar also, students never get chance to ask questions to teachers. Either they are shy or there is not enough time for the because the teachers are interested in finishing the course and things like that. So this platform, which is organized by Pankaj ji and Amarnath ji, we try to complement that. That here students can come and ask questions which they are not able to ask at home or in
Yes.
the school, so they should feel free. At the same
Noted.
time, we want that they should improve their English also,
English
which
also.
is
That's
very
the
important.
yes.
So this is and and of course we are wanting that our children should have critical thinking skills because that helps them to study science in a better way, understand science in a better way. So this is our very simple goal we have. We are trying to complement what is not available in the school or at home.
Sure, sir.
So
Noted, sir.
yeah. So Aryan, so you have any question?
Yes, sir, I had one.
Yeah,
So,
so go ahead.
So, sir, can the birth of quantum mechanics be uh, arisen from the fundamental laws, from the fundamental conservation laws?
Uh, well, this is a very, I would say this is a difficult question and something which I'm not prepared to answer. But one thing I can say, no, it is an idea which has not come from the conservation laws actually. Because you see, our conservation laws mostly were based on the classical mechanics and our experience with the nature. So this was altogether a new way of that how the nature behaves, which we were not aware, say, until even 100 years back. So in last 100 years, we just found that nature is behaving in a very different way at the molecular or atomic level. So I'm not aware that the conservation laws predicts that there is a quantum mechanics. So it is
Uh,
altogether a very different idea.
yeah.
But do you have anything to say? Something? Do you have any objection to the statement?
I just want to add something a little bit, give it as a spin. So basically, knowledge doesn't happen all of a sudden. Sometimes it does, but most of the time, what happens is there is a background, something is happening, and that kind of helps to new knowledge to come up. Okay, so in that respect, if you think, then all the previous knowledge from the Renaissance period, everything is connected, right? And it has helped us because our say previous scientists, they first developed the classical mechanics, and once they have seen the problems classical mechanics is unable to solve, then they started looking beyond that, that what is the new way to solve the problem. And that is when all these new sciences are coming into play. All right.
Yes, yeah, very correct what Amarnath ji has said, And Aryan, the thing is that the classical mechanics which developed from 16th to 19th century, suddenly was not able to explain different phenomena.
Okay,
So
sir.
that's how the quantum mechanics came into being. You see, there were many things which were, and the idea that something is both a particle and a wave was something which people were not accepting. But how it is possible? It's not possible. But then they came to a conclusion that that is the truth. That is how the nature behaves.
So,
So the
as
conservation laws which are there, say related to the energy, the angular momentum, none of them can predict that there should be a quantum mechanics in the nature. It came out of different observations.
yes, so, sir, sir, as you mentioned, the birth of quantum mechanics. So, sir, what are your views on it? Because most of the people said the birth of quantum mechanics happened uh, around Max Planck's time when there was the ultraviolet catastrophe. So, sir, what is your opinion on this?
That is true. That was one thing was an indicator that the classical mechanics is not explaining the things. And then there was the photoelectric effect.
Yes,
Photoelectric effect, by which was discovered by Einstein, and the explanation was done by Einstein. Of course, he didn't get Nobel Prize for relativity. He got Nobel Prize for photoelectric effect explanation.
so,
So
sir.
that paved the way that our thinking of nature is very different than what we have been thinking. But yeah, it was started by the Planck's this thing that he couldn't explain the curves, experimental curves obtained by the black body radiation.
Okay. So,
The
sir,
classical mechanics predicted something else, but the actual thing was only explained when it was made into the calculation that it is a quantum of energy which is being exchanged.
so,
So that gave the right interpretation to the curves, experimental curves, and that was the Planck's.
sir,
Was thinking by mistake he left it.
Okay.
Yes, he will join soon.
Saksham and Earth. What about Saksham and Earth? You guys have any question? I see some new students also.
Um, yes, sir. I had a question that in the last class I asked the question with you.
What was that question, please? Can you repeat?
Sir, about the magnets and the magnetic fields in the last class in the brain, that how our brain creates magnetic fields.
Hello.
Yes, sir.
Malik ji. Yeah. He was asking that I think something to do with our brain creating.
Actually, my mobile got discharged,
Yeah,
so I have switched over to another mobile. Actually,
yeah.
uh, just
Give him
just
a
I'm
second.
taking a break for 1 minute.
Yeah.
I'm changing over the
So,
mobile actually.
Saksham, your question is very high level technical and it is biophysics. So only maybe Malik ji can answer that question. I cannot. I can certainly discuss the certain general physics. So let's see who else is here. Arthras, what question do you have?
Sir, I think so. I can try to answer that.
Oh, good. Go ahead.
So, sir, my view on this that the brain creates some magnetic fields is that when the blood is traveling through the brain, it has some iron in it, so that may create the magnetic fields that he's talking about. So, Saksham, what are your views on it?
So are you saying that because of the iron in the blood,
Yes,
this
sir.
field is created?
Yes, sir.
Is it necessary to have the iron to create a magnetic field? That's my
Yes, sir.
question. So without iron, magnetic field cannot be created. I'm not sure about that.
Uh, Saksham, what do you have anything to say?
Uh, I mean, iron is nothing but combination of just like any other elements. You have nucleus, you have a proton, neutron, and electron in the orbits, right? Of course, electrons are different numbers. Proton and neutrons are also different numbers. So, since we are, I think we really have to go to that level to understand that how the electron, proton, neutron together, they participate in the creation of the magnetic field, not the iron.
Yes. So,
Okay, sir, and I am also having one more question that how many asteroid groups are there in our solar system, like asteroid belt, Kuiper belt, or Trojans?
okay.
Hello. Your
Yes, sir.
question was how many asteroids are there?
No, sir, my question was how many asteroid groups are there which are discovered, like asteroid belt, Trojans, near Earth objects, Kuiper belt, etc.
As far as I know, there are two or three are there. One that has been found also outside the solar system.
Sir, what?
Uh, there are three. Aryan, am I correct? Aryan
Yes, sir.
knows more about it.
Sir, I think so. It's the asteroid belt, Kuiper belt, and the Oort cloud.
Yeah, these are the three. These are
No,
the three major ones. But people have discovered there are many smaller ones are also there.
but sir,
But these are the
sometimes
three
I
major
heard
ones.
about the Trojans and the asteroid belt near the sun.
Oh,
No,
sir.
the asteroid belt like structure near the sun and the Trojans asteroid.
Sir, he's talking about the different varieties. So there are the near Earth objects which may as which come very close to us, and these are and the Trojans. I think so. These are uh, like
Near
massive.
Jupiter, near Jupiter. Like if according to Jupiter's orbit, they sometimes go near Jupiter.
Yes. So, sir, uh, you were talking about the birth of quantum physics.
Yes, go ahead. But I'm switching over to the other mobile.
Okay.
Yeah, I'm switching over to the other mobile just.
So, sir, I had something to say about it. Okay.
And sir, we have seen here Rajesh Pathak. Yes, Rajesh Pathak ji, please say something about yourself.
राजेश जी इंट्रोड्यूस कीजिए अपने आप को। अ, हिंदी इंग्लिश किसी में भी बोल सकते हैं।
Yes. So,
अगर कोई स्टूडेंट है तो देन आल्सो सेम थिंग, if you are a student you can speak in Hindi as well as in English,
sir,
whatever you like.
sir, I wanted to say something about the birth of astrophysics.
One
Quantum.
second, Rajesh Pathak ji.
Sir, he left. I think so.
No, no, he joined.
Okay.
Oh, no, one second left here. Okay, 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 Aryan.
Yes, sir. So, sir, I wanted to say something on the birth of quantum mechanics. So, so what I had to say was that the birth of quantum mechanics happened during the ultraviolet catastrophe. Many people say that, but I think so. The basics and neve was set a little earlier at Newton's time when they were talking about light. So Newton had this idea that light are particles, and there was another person known as Cristiano Huygens. So he developed the probability theory, and he had this idea of light as a wave. So I think so. This was an this was the basic start of quantum mechanics, and it got real when Thomas Young did the uh, double slit experiment where he showed the dual nature of light, and I think so he was also an polymath, Thomas Young. Yes, sir. So this was my opinion on the birth of astrophysics. Sir, you're on mute.
So, the Young's double slit experiment showed that the light is a wave. It behaves like a wave. And
Okay.
it was the photoelectric effect which showed that the light is a particle.
Oh,
So this duality, we in quantum mechanics, you will hear the word duality, duality, duality means something is both wave and particle. So this idea has originated from that, basically. So it was the double slit experiment, which I still sometimes when I think about it, when you go in, say, the honors course, you will be doing this experiment. So that was the birth that people didn't know what light is. So they learned that light is actually a wave.
yes.
It is a wave. And then Einstein comes and the photoelectric effect could not be explained if light is a wave.
Sir. Okay, sir.
So this is where the duality comes, birth of duality comes, and scientists of those time, they did not like to accept this idea that how it can happen that something is both wave and a particle at the same time. So, yeah, you were saying something. What is it?
So, sir, Saksham has a question.
Where is he? Yeah. Then we have, yes, where? Yes, Saksham, please go ahead with the question.
Sir,
So
I have
solar,
the question that what is the difference between solar flares, solar storms, and geomagnetic storms?
oh my God, I won't be able to answer this question. It's a difficult. I'll have to read it and then tell you about what is the basic difference between three. If someone knows, can someone tell?
Sir, I can tell one of them. So solar flares happen when an mass from the sun is ejected. A large mass is ejected from the sun and it comes our way. Yes, sir.
Yeah, and that's because of the magnetic field, by the way.
Yes, sir. Magnetic field disruptions.
Yes.
Let us take discussion back to the magnetic field since Mallikji is back. So
Oh
that
yeah,
was
there was. Was there a
Saksham's,
question on magnetic field?
yeah, Saksham's last week question. We haven't answered his question yet. So
Oh,
Saksham, could you
really?
please repeat your question to refresh Mallikji?
Sir, so what is the difference between solar flares, solar storms, and solar geomagnetic storms or geomagnetic storms?
This is quite a detailed question, and I'll have to read it myself properly to make you understand this. Can you give me some time? Solar flare, I just now Aryan has told is, those are the disruptions caused by the basically disruptions in the magnetic field. So a part of this solar mass comes out and travels all along the solar system. Well, the others I need to study and tell you. See, in science, we all should respect that I may not know all the answers and cannot answer all the questions. So it's always good, to be honest and say, no, I don't know the basic difference between the three. So can you give me some time to answer that? Maybe next time I'll answer your question. I'm noting it down. Is that okay? Or if someone has the answer, then he can answer. But
He
we are
also
talking about magnetic
he
field
also
something.
had supplementary question, which was that he was talking about magnetism in the brain, like how it is electromagnetism created in the brain. So, could you rephrase your question again, Saksham, for him?
Yes, Saksham, can you
Okay,
tell the question once again?
okay, sir. So my question was, what is the difference between solar storm, solar flares, and geomagnetic storm? And the previous question was the how does the brain creates its magnetic field?
So, why this question has come in your mind? Just I want to probe a little bit of your understanding. How this question has come in your mind? Where did you get this question in your mind?
So somewhere like in Google or in Chrome, I have seen that the brain has the magnetic field from 1 nanogauss to 10 nanogauss.
Yes. So
How that magnetic field is created?
Acha, now the question is that magnetic field is created always by a moving charge. Wherever there is a moving charge, there is a magnetic field.
So,
So anywhere there is a movement of charge, there is a magnetic field created.
so sir, is this related to Faraday's law of induction?
Yeah, Faraday's laws of induction is what it tells that when there is a flow of current, means basically if there is a flow of current, there is going to be a magnetic field.
Okay,
And it
sir.
is Maxwell's, he said that if there is a change of magnetic flux, there will be electric field. So
Yes.
electric and magnetic field are complementary to each other and they appear together.
So, sir.
But how the magnetic field is created, of course, is a very interesting thing by a moving charge. But that is a part of the nature, yes. So
And sir, I have
in our brain, there is a lot of electricity going on everywhere. You see, our heart, there is a electricity which is involved in pumping. In brain, there is electrical signals moving around. So you see, all the neurons they work based on the electric principles. So there is all whole body we are electrically not electrical activity is there. So that is where the magnetic field comes.
And sir, I am having that one more question there.
No. First of all, did you get this answer? Means a moving, whenever the charge moves, there is a magnetic field.
Yes, sir.
So, like say in the wire, in the house, you have got a wire. There is a electron flow in that wire. So you'll find there will be a magnetic field. Just try it out in your house. Use a magnet to bring it near a wire. You will find that it gets either attracted or repelled depending on how you are orienting it. So even a wire causes magnetic field in your house. The electric current flowing in the wire in your house.
Okay, sir.
So you should keep on doing few experiments in your house about electric current, magnetic field, electric field.
Okay, sir.
Yes, yes.
And sir, I had the question that we know that the stars have the magnetic field, right?
How do you know that the stars have magnetic field?
Because the heliopause, which is the outer boundary of the solar system, protecting us from dangerous rays from the sun, dangerous rays from the space, is the magnetic field of the sun, charged by its north poles and south poles, and this turns us the sun to the giant magnet.
No, yes, sun has a magnetic field. The earth also has a magnetic field. No, the protection is not the sun's magnetic field. Protection comes, see, we are lucky to have a magnetic field. There are some planets where the magnetic field is too weak, but our magnetic field created in the earth is enough strong so that the solar flares you are talking about, no, those are very heavily charged particles moving at a very high speed. So if they come and strike you, it can cause cancer in your body. But fortunately, we have a magnetic field around it. Magnetic field, what it does, that it diverts all those charges towards the North Pole and the South Pole. It's very interesting, and that is how we are getting protected. We are so lucky, you see. If there was no magnetic field, there would not have been life on Earth.
Yes, sir, and I had the question that when the star dies, it loses its magnetic field or not?
Oh, no,
Like,
this is a very hypothetical. Star dies means if it dies, there is no question of magnetic field. But maybe your question is that in the process of dying, is there
not,
a magnetic field? Is that
not
what you are?
like the
What is it?
like the when the star dies, it
Mhm.
when the you can say that the semi-massive star dies 2.5 times the mass of the sun, it becomes a neutron star. But at the neutron star, the magnetic field is extremely strong, only surpassed by the magnetars. So when the stars which are slightly more massive, so and when they die, they become black holes. So my question is that do black holes have a magnetic field?
Hey, Aryan, do black holes have magnetic field?
Sir,
Uday has also
sir, I
joined.
think yes, sir. Sir,
Oh,
because of their discs, I think so they would have.
Frankly speaking, I don't know the answer, but it should have for the very reason that a black hole is a collection of particles.
So, sir, like the whole black hole, if we do not include its rings, disks, it will not have a magnetic field, but because of its disks, it will have a magnetic field and this charges.
Because of the
Yes,
because
sir.
of the moving, yes,
The material moving in the disk at
yes,
a high
yes,
speed.
Yes, yes, that's correct. That's correct.
So
But
And sir,
magnetic field plays a very big role in our universe. So we have Amarnath ji, you were saying someone has joined.
No,
You can.
Uday is also here now. So we have one more physicist.
Yes,
So
Uday ji, welcome.
Oh, thank you. No, I'm generally in agreement with the explanation being given. So
Yeah, but you can always
about the
add.
black,
You can
yeah, about
always add so that the subject becomes a little bit simpler and understandable by our children.
no, yeah. So you guys, you are right. Both regarding black hole, like I joined when we are talking about the magnetic field in brain. The same
Yeah,
last time also we discussed the same thing, that
right.
all electrical field created in our body, whether it's brain, heart, is the movement of sodium, potassium. Uh,
All right.
one is
Right.
in and out of the cell. Potassium inside the cell, sodium out the cell.
Yes,
So
yes,
movement of them
Saksham,
actually create the electric field.
you can
And
hear the last YouTube where Udayji also made a good explanation of these questions.
sir, does iron play a role in it?
No, no, it's
iron,
nothing. No, it's not related. No, you see, first basic thing is that if there is a movement of charge,
Yes.
so
Oh,
the magnetic field will come into place. If the
yes.
charge is not moving, there is no magnetic field.
Okay, sir.
So it has nothing to do with the iron. Iron has a very special property, which is a ferromagnetic property, which it has. So because it makes domains, wherever iron is there, it makes domains, and they have and they have this because of the domains, it has a special magnetic property.
Yes.
You know,
okay, so I think we have Artharaz, who is the youngest student. Let's make sure that he's also enjoying the discussion. So we are going too far. So Aryan and Saksham, could you please explain to Artharaz what is charge? Maybe he doesn't. He might not have yet studied in his class fifth or wherever he is. So could you guys explain to him? Artharaz, do you understand what is charge?
Yes, sir.
Okay. Then what it is being created?
So I have not understand that much.
What did he say?
Sir, he cannot explain it, but he knows it. He's saying.
that's very good.
Okay. All right. Just for my clarification, can you explain, one of you, Saksham or Aryan, what is charge? How do I explain charge? And explain to me in terms of
the
only not only electron, but
charge
also
is created by the magnetic fields.
So,
charge is created by magnetic field. I don't agree with that one. Uh, it could be the other way around. That's what Maliki was telling you.
sir,
Like I said, electric charges, etc.
sir,
No,
What is charge? My
hello, yes.
question is, what is charge?
sir. Okay, sir. Sir, can I answer it?
Yes, please.
So, sir, charge is a fundamental property. So, when we have an electron, it has a negative charge, and a proton has a positive charge. And when they come together, when they combine, they become a neutron, which is the neutral, and it is an you can say a law that whenever charges are moving, they are creating a magnetic field. So they always come in pairs. If there is moving charge, it will create a magnetic field.
Yes, sir, and I agree with Aryan, sir.
Yeah, but Saksham, so your mind was telling you that it is the magnetic field which creates the charge. No, charge is a fundamental thing. That is what Aryan is saying, and that's very correct actually. Like mass is a fundamental thing, charge is a fundamental thing. These are the things which are there in our universe.
Okay. Now I have another question for both of you, young scientists, Aryan and Saksham. So, we have been talking about electron, proton, and neutron, right? Of course, we know that neutron doesn't have any charge, but electron and proton both do. So, do you think we already discussed that electron can produce charges? What about proton? Can it produce charges? And if it does, where do you see proton creating a charges? Can you give us a couple of examples?
No, Amarnath, what Aryan is meaning, that protons have a charge, which is inherent property. Yeah, it is there in the universe that all protons will have positive charge and the electrons will have a negative charge. And there are other particles are there which have positive charge, like there are quarks which have got only 1/3 of the electronic charge positive, and there are quarks which have 1/3 of the electronic charge which is negative. So there are many particles having plus, minus, and
No,
so yeah,
I was asking that, for example, current
yeah,
flow.
I can understand your question. Yeah.
I want them to understand that current flow can happen not only by electron, it can happen by the holes also.
Oh yeah. So okay.
So
Sir, uh,
that is what I want them to be clear, that it is not only the electron, it is the proton. When we are talking about the charges, either of them could be the source.
yes.
Yeah. Amarnath is driving you all to solid state physics.
Sir, I have a question for you. So,
You are asking Amarnath ji or you are asking me?
Sir,
Or Uday ji? Uday ji.
so sir,
He's
how
asking panels for all of us. Yeah, go ahead with your question.
Right, go ahead.
sir, how does an neutron star have magnetic field? All of its materials are neutrons, and it does not have any charge.
No, by the way, so this is where we say that neutron has a magnetic moment.
But sir, it does not
Surprising.
have a charge.
It is not a charge, but it has a magnetic moment. That is a very interesting property of the neutron.
So, sir,
So
but
if it goes in the magnetic, see, if it were neutral, so if it goes in a magnetic field, it will be undeviated. Means it don't deviate at all, but that doesn't happen. Depending on the spin of the neutron, the deviation takes place. So it has a magnetic moment.
so sir, okay. So, sir, but I always thought that magnetic field and electric field were always pairs. So one could not exist without the other.
No, that is see in the nucleus. What happens is that the latest theory that says is that the neutron and proton, they keep on exchanging charges. So no, can you repeat your question once again?
So, sir, and how does a neutron star have magnetic field? Because it is entirely made up of neutrons.
No, well, that is what I'm saying. It doesn't
Neutron
have a
star.
charge, but it has magnetic moment.
No, neutron star is not.
Why they have a magnetic moment? The reason is that you see they are made of charged particles, quarks.
Yes, sir.
Okay.
So this is very interesting thing. So even the whole thing is neutral, but it comes from there. It has a magnetic moment.
No, sir. What happens that the small part of the neutron star is also made up of quarks. Like they are not only made up of neutrons, but they are also made up of quarks, and quarks are able to create magnetic fields.
Yes.
Hello, Saksham. I do not know which star you are talking about, which are made of quarks. Obviously,
So
if
what
the
happens?
temperature is very
Neutron,
yes.
yes, and neutron stars are, you can say that, not only made up of neutrons, but they carry some amount of quarks.
So,
No,
sir,
neutrons themselves are made of quarks.
Yes,
sir,
sir.
Yeah.
what
Yes.
he's
Yeah.
what
What he is saying?
trying to say is that when in near the core, what happens that the pressure is very high, and I think so quark deconfinement happens. So the chains, the gluonic force breaks down and the quarks are then free. So that is what he's trying to say, that in the near the core there are many quarks there, so which produce the fields.
Yeah. So Saksham, actually Aryan has used a word which is called gluonic. He says means there are gluons. So there are quarks and gluons. Gluons, वो जो एरल्डाइट का होता है उसको लोग glue कहते हैं ना. So there are gluons which binds the quarks. There is exchange of gluons between the quarks. So this is a very high level physics that we are entering. So it is better that right now we don't discuss it, because first we have to understand the behavior of quarks, what they are. But Aryan, can you tell me where did you learn about this gluonic thing?
Sir, I think so. It is what it was in one of the books. I was reading about electron degeneracy force, and after some pages, I got to that topic.
Yeah, so what you have got basically, so when the universe was created, there were no atoms. There were only quarks and gluons. And then when the universe cooled, then those quarks formed into atoms. So now that and the quarks, the exchange of forces happens because of the gluons. So someday we should try to discuss about what is a quark and what is a gluon. They behave a little bit differently than the ordinary atoms. Because I want that your mind should be, should not, suppose I tell something and you should not accept it without questioning it. You must question it. So what is a gluon and what is how they act between the quarks? We'll take it up some other day, actually. We'll take Saksham also along with it so that he also understands. But keep on reading about the quarks and gluons. We all are made of quarks. Most of us don't realize it, but we are all made up of quarks.
And sir, I am having the question that we are made up of atoms and atoms are made up of quarks, but
Correct.
quarks are made up of what?
That we don't know. Right now, we have not been able to divide quarks. See, quarks is something that we are able to create now in the laboratory. But
So these
we
are
have
elementary particles.
Yeah?
These are elementary particles which cannot be divided further. We consider them elementary
They
particles.
are elementary particles right now. Who knows, in future they might, just like, earlier people thought that atom itself means not divisible. But atom got divided into nucleus and electron. Then now the proton has got divided into quarks. Who knows, in future quarks might get divided into something else. We don't know right now. So right now we say quark is a fundamental particle, but it may be in future you all become great scientists and try to figure it out what quarks are made of. हो ही सकता है ना, हम लोग अभी कह रहे हैं ना कि ये फंडामेंटल पार्टिकल है, वो तो एटम भी फंडामेंटल पार्टिकल था 100 वर्ष पहले.
सर हम लोग भी तो क्वार्क से ही बने ना. क्वार्क
एकदम आप, you are made of quarks.
Yes sir, we are made up of atoms and the atoms are made up of quarks.
Correct. Have you seen any quark anywhere?
No sir.
Yeah, but you can see if you become, like say there are laboratories on the earth, like say in Switzerland, they regularly, on a daily basis, they make quarks.
Yes sir, there was a scientist of Norway, I didn't remember his name, he captured a quark.
No, it is nothing to do with the Norway. There is a accelerator is there, where two nucleus, they are bombarded one upon the other, and they break up into quarks. So the nucleus breaks up into the proton break. proton collides with proton and they break up into quarks. And then they study those quarks.
Okay, sir. And sir, I am having one more question that how
Yeah,
does
but Saksham, your questions must come after you do the lot of thinking about it.
Sir,
Yes.
sir,
So
as you
go ahead
said,
with your question. Yes.
sir, that as you said, when we collide them, uh, they break into quarks. But
Right.
the gluonic force won't let that happen unless if it is very powerful.
Yeah, it has to be very powerful. So you see the one accelerator which is there in Switzerland, which is known as CERN, CERN, they can increase the energy of a particle almost to 99.99% of the velocity of light.
Okay, sir.
See, the accelerator which we have in Kolkata, cyclotron, we go only up till 0.6 times the velocity of light. So
Okay.
we cannot create quarks here in Kolkata.
So, sir, but what happens when we try to rip the quarks away is that the gluonic force creates new quarks. So, would the new quarks happen when you try to rip them in that lab?
So no, when the proton collides with another proton, you see the gluonic force which was binding those quarks. So this force becomes too powerful and they break. Now, what is the question you ask?
So, sir, wouldn't the gluonic force turn that extra energy into the new quarks?
No, no, why the gluonic force will give the energy? This why you are thinking that it should give the energy?
Sir,
Like
it broke down. Yes.
like say when let us say one oxygen nucleus collides with another oxygen nucleus. If the energy is less, they'll break up into different elements.
Yes, sir.
They'll break up. But if the energy is very, very high, that is why we need higher energy accelerators. So if the energy is very high, they break up into quarks. One proton, which is right now, we say that it is indivisible, but then it breaks.
Okay, sir.
Yeah. You need very high energy particles for that, high energy collision.
So, sir, is there any chance that an electron may not be an elementary particle?
Certainly, there is a chance, but till date we have not been able to divide electron.
Okay, sir.
So electron continues to remain a fundamental particle.
So,
So we have Archana, no? This is Archana.
is suction.
Oh, that is Saksham, and then Acha. Okay.
Yes, sir.
What are the other questions? But all now, since we are coming at the end, we I am still awaiting your answers to the question that why summer has got longer days and winter has got shorter days. By the way, I want to caution all of you. There are YouTubes, no, they are explaining to students that when the earth comes nearer to sun, then it becomes summer, and when it goes away, it becomes winter. So that is a
no
wrong
due to
explanation.
no sir due to Earth's tilt it occurs.
Yeah, that is what we have discussed, that how the tilt makes that. Right now, you see the earth is very near to sun, but we are having winter. And
Yes, sir.
very soon it will go away further, and then we'll have summer. So the question was that why some in summer the days are longer and in winter days are shorter. I'm yet to receive answers from you all. Hello? Yes, Aryan, you wanted to say something.
No, sir, I had something different to tell you.
What is that?
Yeah. So, sir, I've been studying a new topic. It is called entropy. I did not understand it very well.
Yes. So, so entropy, we say, is a measure of the disorder in anything. It is represented by S. It
So,
is
sir,
universal representation is S. Entropy is whenever something happens, the disorder increases.
so, sir, what I
All the
understood.
processes. So it is a measure of disorder, basically. Entropy is a measure of disorder.
So, sir, what I understood in it was like if we take a room and there are some balls, and if they're enclosed in a very small space, they will be in a very few arrangements. And if the space is large, they will spread out and the arrangements will be more. And that is the thing I understood about entropy, and that is why things never go back to a like small state where there are less arrangements. That's the thing I understood.
Yeah, it is more or less like that. But actually, yeah, but what happens, like say, there is water is there at 10 degrees centigrade. So let us see, suppose you reduce the temperature, then it becomes more orderly, like very near to crystalline kind of things, orderly things. But as you raise the temperature, this order decreases. So basically, entropy is a measure of that. And by the way, the entropy is a difficult concept
Yes, sir.
in thermodynamics, but it is a measure of disorder always.
And sir,
And
entropy is
and
also
and the
hypothetical.
entropy also tells us the universe is going in a time which is forward. What is the meaning of forward time? The
So, sir,
forward time is decided by that increase in entropy.
so, sir,
Anyway, these concepts you will come very soon in your physics books as soon as you get into it. But entropy is a difficult concept, but it is a measure of disorder. जितना
sir, I have a
डिसऑर्डर
question.
बढ़ेगा, जितना भी कोई प्रोसेस होगा उसमें डिसऑर्डर बढ़ेगा.
So, sir, so let's assume that we have an isolated black hole. It cannot consume anything, and uh, and there is some stuff in it, and we do not know about it. We do not know about it, and so what? So will it violate any rules because the entropy is not increasing in it?
When we say entropy increasing, we talk about it. If there somewhere entropy decreases, somewhere else the entropy will increase more than that.
Sir, what?
For example, if you have got a AC machine in your room, so you cool it.
Yes, sir.
You see that AC machine has thrown out the heat outside, and outside entropy has increased. So if I measure the total entropy of outside and inside, it has increased because you have used an AC, air conditioner. So in the room inside, you have reduced the temperature, that means entropy has decreased. But
Yes.
overall, if you take combination of the outside and inside, the entropy has increased. That very soon you will find in thermodynamics, if you calculate these things, you will find that the entropy has increased. तो बेसिकली हम लोग इतना एसी वेसी यूज कर रहे हैं, हम लोग एंट्रोपी ऑफ द यूनिवर्स वी आर इंक्रीजिंग.
So, okay, sir. I added one more question. So, when a black hole receives something, it increases in mass and space. So, does it mean that it has an average density? And is that average density same for all?
Well, I do not know the answer to this question.
So, sir, my question.
Let me frankly admit I do not know the answer to this.
These are hypothetical. We don't know clearly about them.
So, sir, like for 1 kg of mass, it
No,
may.
Saksham says that it is hypothetical. Do you agree with it?
No, sir. Sir, there may be a constant for it. So if it receives 1 kg, it may increase like 1 centimeters in size. and it
Yes,
can.
sir. Yes, sir. How much like if we are putting something inside the black hole, like the black hole is consuming large stars, so its mass and size will increase.
So it would that be a constant? So I think so that should be a constant. And if that is true, it means that it should have an average density, and that should be pretty much same in all of them. And
Since, since I have not, I, did- I did not understand, so neither I will say yes nor no, but allow me to think about it.
so, sir, like we know that a black hole is a sphere, is a place where something enters, it cannot go back. So it means it has increased in mass, and it will also increase in size. And if we add 1 kg to the black hole, it may increase, let's say 1 centimeter. So if that's a constant, it means that it should have an average density, and it should be the same for all the black holes. And at the center or anything near it, the velocities should be same. So I was thinking that escape velocity I was talking about.
Okay, so let me ask a fundamental question to all of you. What is a black hole?
So the black hole is the object in the space-time where the force of gravity is so strong that nothing can escape, including light.
No, Saksham, whatever word you use, you have to explain to me. What did you mean by space-time?
So space-time,
Yes.
I was meaning to say that nothing can escape the black hole. You can say not
Nothing,
even light.
nothing means?
Sir, and not any atoms, photonic particles, etc.
So sir, let me try to give something.
Yeah.
So in black hole, there are two axes, x and y axis. So let we can assume the y axis to be the time and the x axis to be the space. So time is moving up, and so it is moving up like this in space, and it's a region where nothing in time or space can escape it. I think so that is what he's trying to say.
No. Well, I raised my hand, so I didn't understand, Aryan, what you said.
uh, so
Can
sir,
you
it's
become?
like
Can
it's
you make it easier for me to understand?
so sir, like it's cube, and if it is, if I point somewhere, it would be an coordinate, we can say exact coordinates we can get. If we point to a specific place and time at that sphere or cube, we can get its exact coordinates.
No. So suppose to a layman you want to explain, say someone who is studying in class 5, 6,
Okay,
that what is a black hole? Will you say these things? Then he won't understand. So I
so
want you to explain in a way so that our young kids
okay,
can
sir.
understand.
So, sir, in Earth, there are some things called latitude and longitude, and if we say it is on a certain latitude and on a certain longitude, we can find where that exact place is. So this works that way, but the longitude and latitude are replaced by time and space.
No, what has got that to do with black hole? I didn't understand actually.
Sir, I was trying to give a
What is
description for
black
space.
about that and what is whole about that?
Sir, uh, sir, hole is just an word that we use for it. So it is in region where nothing can escape, where the escape velocity reaches, or it is greater than the speed of light.
Yeah, so nothing can escape means even the. So all you have to do is you have to calculate the gravitational force and see that the light cannot escape. Then it becomes a black hole. That is what you are saying?
Yes, sir.
Yeah. So, Saksham,
And not even
do you agree
yes,
with
sir.
this definition?
Sir, I am partially agreed with this definition.
Why you do not disagree? Can you tell us?
Sir, I cannot disagree because black holes do really. Nothing can escape from black hole. Light cannot escape from the black hole.
So Aryan, he says that light cannot escape. That is what Aryan is also telling, that light cannot escape. Then we call it black hole.
No, sir, not only that,
Mhm.
if suppose there is an object of in size of a football, so if we compress the football to its Schwarzschild radius, then it will also become a black hole.
Sure, sure. I agree with you, provided the gravitational force is such that even light, which will
Sir,
any
anything, sir, anything like the human, if we
Mhm.
compress a human to 1000 trillion times smaller than a grain of sand, that
Mhm.
human will become a black hole
Oh
because
my
it has
God,
reached its Schwarzschild radius. So anything, if it reached its Schwarzschild radius, it will form a black hole.
that I agree with you. I agree with
Yes,
you,
sir. I
isn't
have
it?
one more thing. So, sir, when we push something to its Schwarzschild radius, it reaches that specific density. So, at birth, every black hole should be at the same average density, because when we compress a cube into a black hole, and when it reaches the Schwarzschild radius, we cannot push it further. So it means it should have an average density at some point where the light, with the speed, with the escape velocity is greater than the speed of light. So it means all of the black holes at birth had an average density of that same value.
Well, let me think about what you are saying. But then the question I ask is that recently they filmed a black hole. So that
Yes.
means the light came out of the black hole, is it?
No, sir.
Then what happened?
So, sir, it is the disk around it.
Oh, so the disk was emitting, not the black hole, is it?
Yes.
Yes, sir. Yes, sir. Black hole cannot emit the light, but the disk surrounding it can emit the light, known as the accretion disk.
So all of you, black hole is a concept, Uh, so you will have to have a good understanding of theory of relativity, and there are many things are there.
Yes.
It's a very complex subject. There are books and books written about it.
So,
So
sir,
to understand it, go to into depth, which you will be doing very shortly as you study more and more of physics.
do you agree with me when I said that every black hole at birth should have an average density of the same amount?
Actually, I'm neither I'm saying yes or no to it because I'm not able to understand this.
Okay, sir. So let me explain it once again. We have an
Yes.
item and it has a Schwarzschild radius. And let's say if it has a Schwarzschild radius of 10 meters, and
What radius did you? No, every time you use a word, you have to define it properly because
so,
in
sir,
science, every word has a meaning and a very specific meaning only.
sir, a
Like
Schwarzschild
say,
radius.
like say, the ghost is there, no? So different people have different concept of the ghost.
Yes.
Therefore, ghost is not a well-defined quantity. But in science, everything is well-defined. Every word, it means this and nothing else.
So, sir, Schwarzschild radius.
What
Uh,
what radius?
Schwarzschild radius.
What
So,
is
sir,
that? Can you spell that word?
so, sir,
Sir, he is telling our Schwarzschild radius, introduced by
Yes.
Carl Schwarzschild.
sir,
Yes,
it
yes.
is.
Okay.
Yes.
Okay. Yeah, go ahead. Go ahead.
So,
Yes.
sir, if let's assume that it has a Schwarzschild radius of 10 meters, and when we push it to 10 meters, we cannot push it farther because it becomes a black hole. So, and when it becomes a black hole, we cannot push it farther because it has already become one, and it means that it has an average density, where
Mhm.
the escape velocity reaches the speed of light. So that should happen in the case of stars too, when gravity pushes them to the exact to their exact value of the Schwarzschild radius, they should become a black hole where this escape velocity of light becomes greater and it cannot be pushed further.
Yeah, it appears your presentation appears to be okay to me, but
So, sir,
I would like to understand. Can you give me some time to understand what you are saying?
okay. So, sir Uday Jha, what are your views on my uh,
Yeah, Udayji, now he's asking your view. Can you tell what, do you agree with what Aryan is telling?
Yeah. So what is basically trying to say that you have to compress something to such a small extent, a particular, it will reach a radius when it will become a black hole. That's what the question. Am I right?
yes, sir.
And
Yeah.
then he makes an assertion that there should be average density level.
No, that okay. So that the density thing is not right actually. The smaller black hole are supposed to be denser than the larger black hole. Okay. And as far as this particular thing is concerned, that if you compress something, it will actually become a black hole. That's true. That means if you compress Earth, they say to a 1 centimeter radius, at that means the Earth will become a black hole. So you have to compress it to that particular thing.
Yeah, very correct. Yeah,
So, sir, what I meant was that average density. So, when that reaches that, it becomes the speed of the escape velocity becomes greater. And like I was not trying to say that it has its mass, about its mass or something, but about its density. So there must be a small the smallest unit of density where this escape velocity reaches the speed of light. So after that, I don't think so it will be compressed more or it will become any more denser.
Uh, Okay, so basically, the black hole by definition is supposed to be that the density around this event horizon is so high that it observes everything. It does not allow anything to pass through. Okay, that is the basic definition of black hole. But they say that black hole itself can have different densities based on the size. The larger, it says the while the core of the black hole is considered singularity, average density is the mass divided volume within event horizon, which is different for different black hole. So here it's not talking about the black hole, it's talking about the event horizon.
Okay, sir.
So every black hole will have a event horizon and that will have a different density.
Oh, sir.
so I think before we do the final rounding. What about the answer to my this question, Aryan and Saksham, and why it is in summer we have the days durations are longer than compared to in winter? I want
Yes.
an answer to this question.
Sir, I think solstices and equinox are the responsible for this.
No, before in science, what we do is that whenever we answer a question, so when we just don't say anything that we like. We will first critically examine. Suppose I say something, and I will examine it. That what I am saying, does it make sense to me? So if it tells you that yes, it makes sense, then you proceed ahead. If it doesn't make sense to you, then you must try to explore. So now you tell me summer solstice and all these things.
I tell you what,
Yes.
Saksham and Aryan, why don't you guys prepare a presentation as
Yes.
if you are presenting to the a conference? So let's hold. Anyway, we are above time right now,
Yes.
and we have to start another meeting with Amitji, who is a guest here for. He wants to know about our organization. So can we leave this topic for next week, and can you guys be ready to present it, or you need more time?
Sir, I'll try it.
Okay, all right. So
Yes.
that is for you guys to present it, so that we want to see it in the presentation form. You guys will get like 5 to 10 minutes or whatever time you need to explain to us so that we can understand this topic. So I guess with that, can we conclude today? Mallik ji?
Yes, let's. Oh, okay.